Have you ever tried to imagine a world with no zero? It sounds simple, almost trivial. Take a moment and really think about it. Imagine trying to write down the year we are in today, 2025, without a zero. How would you do it? Maybe you'd write 225, which looks like two separate numbers. This small problem hints at much larger chaos. Without zero, our number system would fall apart. Precision would be lost. Big ideas would be hard to write down. Technology, as we know it, couldn't exist. The absence of zero would create confusion in basic tasks. At its most fundamental level, zero is the silent hero that gives our other numbers their power. Its first and most important job is to be a placeholder. Think about the number system we use every day, the decimal system. In this system, the position of a digit tells you its value. In the number 25, the 2 means 2 tens and the 5 means 5 ones. But what happens when you want to write a number like 205? You have 2 hundreds and 5 ones, but you have no tens. This is where zero steps in. By placing a 0 in the tens column, we get 205. Visual. Simple diagram showing the place values of the number 508, with arrows pointing to the hundreds, tens, and ones columns, highlighting the 0 in the tens place. That 0 isn't just empty space, it's actively holding that place, shouting, "There are no tens here." Once 0 was accepted not just as a placeholder, but as a number in its own right, mathematicians had to figure out how it behaved. They needed to establish the rules of the road for this strange new quantity. The first rules they discovered are ones we learn as children, and they reveal zero's unique identity. If you add 0 to any number, the number doesn't change. For example, 7 plus 0 is still 7. Likewise, if you subtract 0 from any number, it also remains unchanged. 15 minus 0 is still 15. In the world of addition and subtraction, 0 is the identity element. It's the neutral party that leaves everything just as it found it. This property is more important than it sounds. It provides a baseline, a point of stability in the often chaotic world of numbers. Things get more interesting, and much more powerful, when you start multiplying with 0. The rule here is absolute and unwavering. Any number multiplied by 0 equals 0. It doesn't matter if it's a small number like 3 times 0 equals 0, or an enormous one like 42 million times 0 equals 0. 0 has the power to annihilate any other number through multiplication, reducing it to nothing. This single property is a cornerstone of algebra. The story of 0 is not a single flash of brilliance, but a slow, creeping dawn of understanding that spanned centuries and continents. The first whispers of 0 came from ancient Babylon, around 500 BCE. The Babylonians had a sophisticated number system, but they faced the same problem: how to distinguish between numbers like 204-24. Their clever solution was to use a symbol, 2 slanted wedges, not as a number, but purely as a placeholder to signify an empty column. It was a brilliant hack, a way to avoid confusion in their astronomical calculations and records. However, they never truly conceived of this placeholder as a number itself. It was a punctuation mark, not a part of the numerical vocabulary. The true breakthrough happened in India. Around the 7th century CE, Brahmagupta did something revolutionary. Once 0 was established as a number in India, it began a remarkable journey across the world, transforming every culture it touched. Its first major stop was the flourishing Islamic Golden Age. Arab scholars, Persian scholars encountered the Indian system in the 8th and 9th centuries. The great Persian mathematician Al-Khwarizmi, instrumental in this process. He wrote a book introducing the Indian numerals, including 0, to the Arabic-speaking world. He praised the system for its elegance and efficiency, especially the power of the humble 0. The Arabs called it sifr, meaning empty. The Hindu-Arabic numeral system spread rapidly throughout the Middle East. It was a perfect tool for the explosion of science, astronomy, commerce. The widespread adoption of 0 was not just a mathematical convenience, it was a catalyst that fundamentally reshaped society. In the world of trade and finance, its impact was immediate and profound. Before 0, bookkeeping was a messy, error-prone affair. Using Roman numerals to add or subtract large sums was a task for specialists. But with the Hindu-Arabic system, any merchant could easily track their inventory, calculate profits, manage debts with clarity and precision. The concept of a zero balance, neither profit nor loss, became a clear and simple idea. This newfound numerical literacy fueled the growth of banking, credit, international trade, forming the bedrock of modern capitalism. In the realm of science, zero was nothing short of a revolution. If zero was important in the age of trade and science, it is absolutely indispensable in our modern digital world. Every single piece of technology you use, your phone, your laptop, the internet itself, is built upon a simple language with only two characters, 1 and 0. This is the binary system, and 0 plays a starring role. In the microscopic world of a computer's processor, a 1 represents the presence of an electrical pulse, an on state. A 0, conversely, represents the absence of that pulse, an off state. Every photo you take, every email you send, every song you listen to is, at its most basic level, an incredibly long and complex sequence of these ones and zeros. This binary language is the alphabet of all digital information. The 0 is not just a placeholder here, it is one of two fundamental states of being. It is the no to the yes, the false to the true. Without 0, there would be no binary. We would be stuck with an unary system, a simple tally, which is completely incapable of handling the complexity of modern computing. While 0 is a king in the world of mathematics, its influence extends far beyond, into the deepest questions of science and philosophy. In physics, the concept of 0 is not just a number, but a representation of absolute states. Consider temperature. Celsius Fahrenheit 0 as a convenient but arbitrary reference point, freezing point of water, brine mixture. But the Kelvin scale is different. It features absolute 0, 0 Kelvin, atomic motion. Ceases molecular motion. Ceases. It is the coldest possible temperature in the universe, a true physical 0 point. It represents a state of minimum energy, a fundamental limit of nature. Quantum mechanics gets weirder. Even the vacuum of empty space, which you might think of as a perfect 0, is anything but. After journeying through history, science, and philosophy, it's easy to see 0 as a grand, abstract concept. But the truth is, 0 is also a humble, hard-working number that shapes our daily lives in countless ways we often overlook. It's an invisible architect, quietly structuring our reality. Every time you check your bank account online, you are interacting with 0. A balance of $500.00 uses zeros not just as placeholders but to signify precision. It tells you there are exactly 0 cents, not 1 or 2. That 0 provides a certainty that is crucial for our financial world, from personal budgets to global markets. Think about the way we measure the world around us. When you step on a digital scale, it first flashes 0.0 before you step on it. This process, known as tearing, establishes a 0 point, ensuring that the measurement reflects only your weight. This same principle is used everywhere, from a kitchen scale measuring flour to a scientist's highly sensitive laboratory equipment. Temperature forecasts often hover around 0 degrees Celsius in the winter, a critical number that tells us whether to expect rain, sleet, or snow. 0 acts as a crucial threshold, a dividing line between different physical states that directly impacts our daily decisions. The modern world stands on the shoulders of this humble hero, 0. Consider the difference between the numbers 13 and 103. They both use the digits 1 and 3, but their values are vastly different. The 0 in 103 is doing critical work. It pushes the 1 over into the hundreds place, instantly increasing its value tenfold. Without that 0, 103 would collapse into 13, and 103 pounds in your bank account would suddenly become a mere 13. This ability to signify nothing in a specific column is the secret ingredient that makes our numerical system so powerful and versatile, allowing for both tiny fractions and astronomical figures. Ancient Romans, for all their engineering marvels, struggled with this. Their system of numerals, like I, V, X, L, C, D, M, had no placeholder 0. Writing large numbers was cumbersome and performing calculations was a nightmare, often requiring an abacus. The genius of the system we inherited is that we only need 10 symbols, 0 through 9, to represent any number imaginable. The 0 is the key player that makes this elegant efficiency possible, acting as the grammatical glue that holds our numerical sentences together. So, the next time you see a price tag for $20.50 or check the odometer on your car and see it tick over to 100,000 miles, take a moment to appreciate the zeros. They aren't just signifying absence, they are performing an active, essential role. They are the scaffolding that gives our numbers structure. The quiet guardians that ensure a million is not confused with 1,000 or 100. Zero as a placeholder is the first step in understanding its profound importance. It's the foundation upon which all of modern mathematics, and by extension, the modern world itself, is built. It is the most important nothing you will ever encounter. From an ancient placeholder to a digital powerhouse, zero has done more than just create the modern world. It has become its silent, unassuming operating system. It is in the binary code that streams this essay to your screen, in the coordinate system that guides your GPS, and in the timeline that organizes our history into BCE and CE around a conceptual 0 point. It is the most powerful nothing we have, an invisible architect whose work is so fundamental that we couldn't imagine our world or our lives without it. Zero wasn't just a tool, it was the enabling concept that unlocked higher mathematics. It turned chaos into order, making the modern world possible.